Hi everyone, again welcome to this lecture of the LPS course, which is the programming class. We will be looking at the tickle programming. We will continue with the tickle programming. Today I will go through some of the some more advanced topics on the tickle. Before that, I just wanted to mention a quick recap of what we covered in the last class, the last lecture. We continued our string substitution. I mean the strings and lists and various data structures. We started looking at the procedures, and as you know, the procedures have like three main sections. Actually, if you are counting the number of arguments, there are 5, and then the first it starts with the keyword proc, then followed by the name of the procedure, then some set of params, then it goes into a body essentially. Actually, the four main parts essentially, and then when you and most of the tickle scripts are written with these procedures. So it is basically starts with proc, and then your procedure name, followed by params, and then followed by the body. As you know, like I mean, you need a blank space here. This you can put a parenthesis, and this is again parenthesis. I mean, sorry, the braces, the double braces essentially. So and then the return value typically is you can specify it as return at the end of the procedure, or if you don't have anything written, the last evaluated function, that output will become the output of the proc. And then we also looked at how do we specify the params or the arguments. What if we want to do it with we have like many number of params, a variable list, variable length parameters. Then we can use the keyword args, which kind of it stores in a list of all the values. So every time you call the proc, the number of arguments can be different, and it will take it as is. We also looked at some of the scope related issues, which is by when you use the variables, how do we determine the scope which is inside the proc, and if you are setting it outside, like say set x10, then now if you want the x to be used inside the proc, what will it be? So to get this x into the proc, we use this command called glob, which is essentially I mean actually the glob global. The global command actually gets this value, and then global x basically confirms that actually the x that is defined here, that value can be used inside the procedure as well. Again, point to note is the global x command itself is not setting any value to the variable x. That needs to be set outside. It's only make sure that whatever is set outside can be read inside. And then we have like a couple of other things. Basically, if you want to communicate a particular value of the variable, that means that say like you want to edit this one basically without specifying this, and then say like inside the proc you are saying like set x10, and then this x wants to be visible outside the proc. The way to communicate is through using the upward. And then so you can specify saying that my upward x is actually or $x is whichever value in the previous one. Say here it is actually y, then you can say it is y. So this 10 whatever the changes that brought back to the y after executing the procedure. Same thing, like I mean we also have like up level. Actually, yeah. So the up level, we saw that basically it is to communicate a script back to the top level. That's where we use up level. So we saw that, and then we also saw some of the main rules of Tickle. I mentioned like 6 rules. Uh, 6 rules of Tickle. I hope you remember all those things. Essentially, I'm not going to repeat, but just in case, like I mean, so the main 2 things are the variable substitution. This is through $, and then the command substitution. This is using the square brackets. So these are 2 main rules, and then other than that, the rule about the interpreter versus the parser is important. Interpreter takes in a command and then basically just splits it into words based on blank space. As you know, like the blank space is the delimiter for words inside the command, and then this is sent to the parser. The parser parses this command, and it knows like how many variables need to be there for the given command, and then it processes accordingly. And this can be like recursively called, meaning like the command again once again it sends the thing. If it has another command substitution, maybe it will send it back to the interpreter, and then it again like goes through. So recursion is possible in the commands. So the key thing is, okay, so then the blank space, and then for separating out the commands we need to use the semicolon or a new line. So these are all various rules that we saw, and then the remaining rules are pretty much exceptions to these rules, meaning like if you want to group the soft grouping and the hard grouping, with the braces, and then the soft grouping is through the quotes. And the difference between this and this is any kind of special characters can be substituted inside this, whereas here it is not substituted, and then it is treated as the same. So we went through all these different things basically in the last lecture. I hope it's right now, like I mean, you're much more capable of using Tickle, and then probably like I mean you can use Tickle for programming your various assignments. And a couple of other things also we mentioned was how to actually use some of these commands to provide documentation or help commands, things like that within the proc itself. And then also like I mean we can so there are some guidelines for making sure that the programs are correct from the get-go. We talked about all those things. So today we will be talking about the TCP ports sockets, basically like how to set sockets with Tickle, and then how do we communicate between various servers using Tickle. And then finally I have one example that we will will go through it. There are some concepts that we learned in that example. We will see how those concepts are. These rules, the 6 rules that I mentioned, are also like explained there. So we will see how those things play out, and how does it work? How does Tickle work in a big command? So let's look at first of all some of the networking items. So we saw in the very first lectures as to how the whole networking works. We know that there are layers of abstraction. We defined the 7 layers for defining the a network. In a TCP scenario, it could be just 5 layers, but essentially, and then the lowest layer is essentially the physical layer, which is essentially it's a wire that is that communicates between or sends the real packets or real data between the 2 computers. And then we also saw that how the internet is using this TCP/IP protocol, which is shown here. And then we saw in fact even the IP addresses, basically like the IP addresses are the long values essentially. It's like a 32-bit number divided into like various octals essentially. So and then we also knew that actually how to code all these values. What is a subnet versus the main network address. And then there are also like port numbers in networking. Usually we use the port number 80 for any of the web traffic, and then 25 is used for the mail traffic. So these are all like physical ports opening in the various servers, and then we can use this to actually build pipes through which we can communicate. And traditionally these pipes are known as sockets. So these sockets are built on top of TCP/IP. We actually saw some of the sockets even in earlier versions as to how we can use Unix file system across network. So the sockets, essentially the main function of the socket is it listens on a port for any connections, and then it contacting a port on some machine for a service. So those are the 2 things that the sockets can do. One is if it is in the current machine, it listens for the port for any connections that is being established, and if you are communicating to another machine where your machine is more like a client and the other machine is a service, then it basically polls that machine. Once the socket is established, it polls that machine for service. So these are the 2 main things that you may want to look into. And then the Tickle already has a built-in simplified socket library. So let's look at how Tickle works in this scenario. So Tickle has a built-in procedure called the socket, and which creates this network connection. Here there is a quick example: set F socket and then the address and then the port number. So now tell me how many arguments does socket command have? Actually there are only 2 here, which is one is the IP address, and then the other one is port number. Actually there's also an there's a additional argument that you can specify, which is this accept essentially, and then when we specify the accept, actually we turn a particular machine into a server. And so essentially, like this means that actually it's a server socket. So your machine is now going to act like a server, and it will service the request from other clients. So let's continue with this one. So the other one is like the fconfigure. Fconfigure whatever this socket that we got, and then basically like we put some buffering on it, and then the buffering is per line. So every line, the first line when you get it, like the first line is also stored as a buffer, and then the subsequent lines, basically the previous line is stored in the buffer line. And then basically we just use get, and then basically we just read the socket and then write outside into this after this get. So now if you run this code, essentially like this loads the HTML from Sun's homepage. Now anyway, the server, the socket is basically like socket minus server accept, and then which port number that you want to open this socket on, which you can specify it as 80. Again, we talked about this in the Unix lecture. The entire network just looks like a large file, so that's why you can actually work these kind of things. So in order to execute certain processes, we can have like two things. One is we can use an exec command, which is shown here, and then we can also use the ampersand. So here we are starting Emacs by basically setting the favorable editor to Emacs, and then executing the favorite editor with ampersand. So this actually opens up a new window with a new Emacs window, and it won't obstruct the main process that is already working on. And then the file name expansion itself, like we don't have to do it. We can use the glob command to do it. So here a quick example is ls glob star.c, that gives you all the C programs essentially. And then if you want to open pipes,